All right, guys, in this video, we're going to do EOC review number 16. Again, in this video, we are comparing now linear functions, quadratic functions, and exponential functions. So all three, instead of like in number 14, where it was just linear and exponential. So label each table or graph as the following. So in table number 1, we have our exponential function. In table 2, clearly, or graph 2, we have our linear function. And in graph 3, we have our quadratic function. Now let's look at these tables and determine which we have. So in table 1, we're always going to look at table number 4, sorry, we're looking at our y values compared to our x values. So our x values were just going up by 1, okay? Our y values, remember f of x is the same thing as y. Our y values were increasing by a constant rate of 3. And if we're increasing by a constant rate, then we have a linear function. In number 5, let's see, I'm going up by 1 in my x, so that's all consistent. But what's happening to my y value, my f of x value? Well, 1 to 2 and 2 to 4 and 4 to 8, I'm multiplying by 2 each time. So that's a constant ratio. And when I have a constant ratio, then I have an exponential function. Now in number 6, again, my x values are just going up by 1. But what's happening to my y values, my f of x values? Well, from 1 to 2, I added 1. From 2 to 5, I added 3. From 5 to 10, I added 5. And 10 to 17, I added 7. Well, that's not a constant rate, but when I look at my second difference, I should see a pattern. So from 1 to 3, I added 2. From 3 to 5, I added 2. And from 5 to 7, I added 2. When you have the same, a constant second difference, like we do here, then we have a quadratic function. From the tables in problems 4, 5, and 6 above, which function will have the largest f of x function? So which one would be the largest? Well, if we're dealing with linear, exponential, and quadratic, our largest value is always going to be our exponential. So our answer here is number 5, which is the exponential function. And that's because the rate of change is the highest. All right, let's look at number 8. It says the table gives the regression lines for the population of the United States from 1900 to 2010. So one is a linear model and the other is an exponential model. Which one is exponential? Well, to determine that, I have to look at my change. So first I'm going to look at my g of x. So to go from 61.72 to 82.82, I added $21 or 21.10. We're not talking about dollars here. So 21.10. To go from 82.82 to 103.92, I added 21.10. So I'm adding in each one of these changes, so plus 21.10. So that tells me that my g of x is my linear function because I'm adding a constant value, a constant difference. So that means that my f of x function is then going to be my exponential. And if I look at this, I can tell that it's going to be multiplied by about 1.14. Okay, I'm multiplying each one by about 1.14, and that's my exponential rate. So which model will predict a larger population in 2020? Well, that's definitely going to be my f of x model, the exponential one, because my exponential function always has a higher rate of change. Okay, and number 9, the graph below shows two functions. We have our p of t function, which is this linear function, and we have our r of t function, which is exponential. Which function will have the larger value when t is equal to 20? Well, remember, with our exponential functions, okay, if we're looking at a linear versus an exponential, our linear function is going to go like this, where our exponential function is all of a sudden going to spike. So no matter what, our exponential function is always going to grow at a faster rate, and if my t is equal to 20, then I know that my r of t function is going to grow faster. So r of t grows at a faster rate. Therefore, when t is equal to 20, that will be my greatest value. All right, that is your EOC review number 16. I hope that helps.